All right, welcome back, everybody. I am excited to be back with you today. We are starting a new section called logical operators. You can think of this as kind of a bolt-on to conditional code. So a lot of what we do is going to really build on that last series. So if you haven't seen the last video, you might check that out. Or if you're not familiar with conditionals, you should definitely check that out. Without further ado, let's get started. So we talked about doing ifs and elses in the last section, and I think everyone's pretty familiar with that now. Great way to help run code if a condition is true or false. In this, what we're looking at is what if we want to do two conditions and say if both conditions are true using the and, if either condition is true using the or if we want to reverse a condition, make a false a true, make a true a false, something like that. And so what we're going to do is try that out with logical operators. So like I just said, logical and only runs if all conditions are true, blocked and on a gem in this case. Logical or code runs if at least one condition is true. So on a gem or on a switch, then do a dance. Just like that. And then the not operator, it's going to change what it is. So if on gem is true, the exclamation point, sometimes called bang, on gem will make it false. So if not blocked, fly away. Just like that, we just say instead of if is blocked, we just add that little exclamation point. And you're going to get it really quick. So let's just go ahead and start the coding. And let me reset this playground. And let's talk about what this puzzle is. So they want you to write some logic that is going to change up the behavior when you're not on a gem. So you'll notice I'm on a gem. I'm walking down this column. I'm on a gem. I'm on a gem. I'm not on a gem on the third. And then I've got this gem off to the left. And then I'm on a gem again. They are actually going to randomize where this staircase is and where this gem is, but it'll always be the staircase and the gem will be on the same row here. And correspondingly, there will be no gem. So they want us to practice that. So before, what we would write is if is on gem, we would then say collect gem. And that works great. I'm going to boost that up. There we go. And we liked that, but what we're trying to do now is say if not on a gem, then we need to make that turn, go collect that, and come back. One thing before we get into that, I'm going to write our turnaround function. Just so we have it, turn left, because when we get to the bottom there, we're going to need that function. Once again, good just to practice that. Do your functions. The more you write these little baby functions, the easier it is when you're like, oh my gosh, how do I write a function when you actually have to? So, sorry, need a sip of coffee, and let's keep going. So first thing we want to do is turn left, and then we're going to walk down twice, and then we're going to collect that gem. Then we want to turn around. Recognize my thing. There we go. And then we're going to move forward twice. And then we're going to turn left again. Because we're facing the opposite direction now, to get us back on that column, we're going to turn left. There we go, guys. Okay, now we have handled what will happen if we move forward and we end up not on a gem. Let's do an else. And the only other condition there is, are you on a gem or are you not on a gem? So if we're saying if you're not on a gem, you're going to do that thing, but the opposite would be you're on a gem, then we don't have to ask another conditional. We can just say collect gem, and that would work just fine. So they've already built us this little for loop for I in 1 ... for. Here's our move forward first. Check if we're not on a gem. If we're not on a gem, we run down, run back. Collect that gem down there, and otherwise we're just going to collect the gem we're on. So let's see what we get here, guys. And you'll notice they did randomize that that stairwell or that staircase because that was on the third spot when we were building it, but it was on the second spot when we ran it. So hope that's clear. I think they're going to do one more not, and then from there we're going to move on to and. Okay, use of not operator to turn when blocked. So this is kind of a fun one, and it's nice and easy. What they're basically wanting us to do is they're going to create a different spiral here each time, but they are going to randomize where the turns hit. So it might be a really wide spiral that has a long path in the beginning, or it might be a really tight spiral. But anyway, the way we behave here is if we're blocked, meaning we can't move forward, then we want to turn left. Oh, I'm sorry. Let me reset this before I just totally give away the answer. It's okay if you see that. It's not a big deal, but I think us walking through it is going to help a lot too. So what they want you to do is if you're not blocked, move forward. If you are blocked, then you want to turn left. So what we would do is, first thing we would do is if not is blocked, then we would say move forward. And then we would say else turn left, move forward. And then we can also put another one in and say if is on close switch, toggle switch. That way we get that switch at the very end. And let's just run this and see what this gets. I think this is actually pretty close. There's lots of different ways to do this, guys. So you might change up your conditional that you ask, or you might change up the order of things. Sometimes order is not important. Sometimes order is very important. So try it and test it and see what you get. There we go. It worked for us. So let's keep going. And if you guys come up with a really clever solution on any of these, I'd love to hear about it. So feel free to message me through YouTube. Feel free to leave a comment. Man, if you like this video, go ahead and subscribe and like it and all that good stuff, because that always helps, especially as I'm trying to build this coding tutorial thing. The more people like it, the more people get to see it. So that's kind of how YouTube works. All right, let's restart this guy. Start page over. All right, this is going to be a little bit similar in terms of rules. So what we're doing here is we have this center column, and on the left, if we're blocked and we're on a gem, then we're going to have to run up a stair. But if we're blocked on the left but we're not on a gem, that switch is already activated, so we don't need to do anything about that. So really the only thing we're trying to cope for here is what happens if this is a situation like this and this. And that means we need to run up and grab that switch. Otherwise, we're just moving down this column. So 1, 2, 3, 4, 5, 6, 7. So that's what they've already written for us. They're just moving us forward along this column. If we were to run this right now, he would run all the way down the column and he'd be done. So this is where we start playing around with the double ampersand, meaning the logical and operator, so that we can have two conditions on our if statement. So if we were to handle this, first, because I always love writing this, function, turn around, turn left, turn left. And, if it's easier because we already have something called turn, you could call it something different, like we don't have an A really. You could call it about face, like what they do in the military. And then you just call that. So let's start out with our if statement. So we want to know if is on gem. And if we just went with is on gem, then this one right here would fail, that second gem in the row, because we actually cannot turn down that way and grab a switch. Pardon me, a little more coffee. So we need to do that, and is blocked left. And so they gave us that to say if you're blocked on your left side. And those are the two clues that tell us we need to then turn right, move forward, toggle switch, about face, move forward, turn right. So that would be the block. So we're turning right to face that little tiny column. We're moving forward twice to position ourselves on that switch. We're then toggling that switch. Then we're doing our about face or our turnaround that we've been writing. Just turn around and face the other way. Moving to get back on that central column, and then turning right to orient ourselves back towards the forward position. So right there, we've already written our logical and conditional that helps us know that. The only thing else we need to do is just say if is on gem, collect gem, because we want to collect the gems as we walk down this way too. So let's take a look and see what we get. Got it? Got it? Got it? Ah, see? And that's something interesting. I was almost afraid for a second that we missed that gem, but the gem comes after we make the run up the column. And so that's totally cool. You could reverse those two things. You could check for the gem first and then check if, well, actually you could not. I'm sorry. If you did that, then you checked is on gem and is blocked left, it would fail. And so you don't want to check for the gem first to collect the gem. You want to check if you're blocked left and on a gem. So we did it in the right order. Order is important in some areas, and that's a great example of one. All right, let's start this page over. And this one is interesting because if you look at this one, in the beginning you're like, what the heck? It doesn't really have a great pattern to it. I'm not understanding. So what they're trying to get us to do is look at that logical OR operator, and they want us to write a conditional, an if statement that will turn us if we are blocked. And so if I let's start out with just a move forward here. Or actually, let's do the move forward last, because I think that's going to be important. So let's start out with our logical operator here. We're going to say if is blocked, because we know if we move forward once, we're going to be blocked in the front. And so we want to turn right. And we could just start writing that. We could say is blocked, turn right. But we'll turn right, and then we'll move forward, and then we won't catch that we need to turn here. This column right here, the second column, is actually the signifier that we need to turn right again. And so we need to say or is blocked left. So when we're blocked left, we're going to turn left again. Or we're going to turn right. So if either of these two things are true, in this first case, when I move forward, it will be true when I'm facing that wall, and it'll turn right. And then I move forward, nothing happens, move forward, and then look, I'm blocked on my left here, and so then I'm going to do another turn, because left is blocked left or is blocked, one of those two is true. So we're going to turn right. And that's about it, but I do want to say if is on gem, collect gem. We can't forget because we like gems, and so let's go ahead and collect that while we're there. I think you need to do it to win the puzzle. And you'll notice they already wrote this for loop to say, hey, you should be able to do this in 12 turns. You could write a different loop where you do this in 14 or something like that, but it's really great to just follow what they're setting up, because they're really kind of setting a really good structure and framework here. All right, guys, let's keep going. I should say guys and gals. I will change that. All right, let me restart this one real quick. All right, new code. So the only thing they're giving us is 8. 8 in the loop. And they're saying 1, 2, 3, 4, 5, 6, 7, 8. So by here, we should be able to complete it all. And so there's a couple of things we need to do. So this is a challenge where we can use our not operator, our and operator, and our or operator. I'm going to write it out just the way it makes sense, and then let's make sure we're using all three in there. So let's start out. The first thing we know is if we're blocked on the front and we're on a switch, if is on close switch, and actually it should just be, let's see. I get it here. I'm on a closed switch. I need something more additional than just is on closed switch in order to do this. So is blocked and is on closed switch would help tell me I need to turn left here. What about this one though? This is an interesting one. So I'm not blocked in the front, but I'm blocked on the left. So this may actually be two different conditionals here. Let's just play around and see what we get. And like I said, there's going to be multiple ways to solve this, so let's not worry too much about it right now. And is blocked. We're going to want to toggle that switch, and we're going to want to turn left. So that would handle that right there. We would successfully turn. We could say if is on closed switch and is blocked. Is blocked right? Let me think about this. Do we get is blocked right? Let's see what we get. Toggle switch. Turn left. Let's start with this code and just make sure that that's going to run. All I want to do is make sure that I walk around the loop right now. That's the only thing I'm trying to do. Yep, sure enough. Okay, so that works. That was actually pretty good. So we've actually solved two of the switches. One thing we notice whenever we need to go out and get a gem and come back, there is both a switch and a gem. So let's start with that one. If is on closed switch and is on gem. The first thing to do, let's collect both the gem and toggle the switch. That way we've got that done. We're always going to be turning right, moving forward twice, collecting that gem. Let's do our function about face. I like that a little better, so I'm going to do that for a while. Turn left, turn left. Now we've got our about face or our turnaround. Takes a second for them to recognize my functions. We'll move forward again, move forward again, and then we're going to turn right. So now we're back in that little U-shaped area that we want to be at, and we're facing the right direction. We know we don't really need to, let's see, we're handled with this. There is a situation where we're just on a gem. And so at the bottom here, let's say if is on closed switch or no, let's just say is on gem, because that's the simplest. Collect the gem. So we've written some ands, but we haven't used a not, and we haven't used an or. Let's keep playing, and we'll find a way to use those. And we don't have to use them all, but let's play around and maybe we'll keep running and we'll see if we can't find this. So let's just talk through what we've done. We're moving forward through the thing. If we're on a closed switch and we're blocked, then we're turning left. And then if we are on a closed switch and if on a closed switch and blocked right, then we're toggling that switch again and we're turning left. So that handles our two corners here. We are then is on closed switch and is on gem. So that handles these little out and backs that we see here. And then that last little gem right there. I think this is going to handle everything we're looking for, but let's just see. Once again, this feels cartoony, but this is really the process that you'd go through if you were writing some software. You would write a little bit and you would test it out and make sure that it handles this little sub thing you're trying to do. Then you would expand it out and say, okay, now how about this thing that I'm trying to do? And now how about this thing that I'm trying to do? And as you build it, it really becomes this full-fledged program. And so keep going with this. This really is a fun way to do this. Okay, so we got everything done that we needed to. We could, I wish there was a way to just reset this. If I click here and I step through code, and then I just stop, that's going to get me pretty close. Let me do that and then stop. That way we're reset at the beginning. I'm just looking real quick to see if there's a not we could use. I mean, we could always say if not is blocked, move forward, because we don't want to move forward if we can't move forward. And so that would be a way to put a not in there. What about an or? I'm not seeing just something that's super obvious to me on an or. We could, I don't want to get too far ahead, but there is actually a way we could do an or in here to combine these all into one. But I'm afraid that that might be just slightly confusing, so I think I'm going to wait on that. So I'm going to run through this on the fastest now that it's, not is blocked. You can see it doesn't really change anything. It adds another conditional. We could take it or leave it. It would add in a little bit of check safety for us and just help ensure that we are truly able to move forward. If moving forward incorrectly produced an error, then we would definitely want to check for that. The playground is very safe, and so it doesn't do that, but there are situations in coding where that might happen. So with that, we have finished the last logical operators challenge here. I would love to hear from you guys. Here if you're liking the videos, here if you want to see something else. After I finish these really basic ones, I'm going to continue on to the more advanced ones. That way you can see how you build skills into building games or any other playground that they've got. So they really do have some cool ones about building like a brick breaker game and adding features to that. Many others, but the foundation stuff is really important to get. So if you've never seen Swift, if you've never done programming, great place to start. Please continue on these videos. And I will keep releasing them until I get through all of this. But I have enjoyed our time together today. Thank you guys and gals for watching. And give it a shot. I believe you can do it. I believe in you. Have a great day.